All right, so let's do number 45. So a 420 grams block, so I'm just going to say that the mass here is going to be 420, and I'm going to presume you guys know how to convert. Um, it's at rest on a horizontal surface. The coefficient of static friction between the block and the surface is, so I'm going to write this down. The coefficient of static friction is going to be 0.72 newtons. Make sure you know what this is, folks, because, oh, not newtons. Because, because there is a difference between static and kinetic friction. And it's kind of hard for me to explain it because I suck at explaining everything. But I will do the math. I do understand this very well. So, I mean, so I will set this up correctly. That's not going to be a problem here. Anyways, you're given the values of the force of the coefficient of the kinetic friction and the static friction. All right, so a force of magnitude P pushes the block forward and downward as shown in the figure. So I'm going to redraw the forces diagram right here. And I'm going to just draw this because it's easier if I just look at it from here. And I'm going to push it at this angle right here. At that angle, assume that the force is applied at the angle of 37 degrees below the horizontal. So that means that this right here is going to be 37 degrees below the horizontal. Um, Beautiful. I'm gonna watch Star Trek tonight after this video. Fuck this. Been doing a bunch of physics problems and I'm behind on the animals at the moment, so I'm gonna take another 10 milligrams of THC and just gonna watch Star Trek. Anyways, what's that? Um, but once you guys understand this is pretty fun, and I want to make this clear, folks. I'm, you know, these problems, in my opinion, they should be read because these are pretty hard to conceptualize because we're talking about all the cases of P, and you're changing two scenarios. You're talking about a case where the friction force is always going to be equal to the force of the component of your pushing it. Well, let me just redraw this. So this is going to be the force of the friction, and so if you push it in this direction, then there's going to be friction in that direction. And then of course there's going to be a normal force, and then there's going to be the force of gravity. So let's sum up all the forces to get this out of the way. So the sum of the forces, actually I'll put it right here. The sum of the forces in the x would just be P sine of theta, presuming I interpret the problem correctly. If not, whatever, then put cosine, or if it's the other way around. And I think I did. I think I drew it correctly. So minus the friction. Notice that I don't want to put the coefficient times the normal force. I don't want to put that just yet because that's not always the case for the static friction. This value always varies. So this is not a constant value. I know it might say that on the textbooks. I don't know what, in fact, to be honest, I really don't know what it says on the textbooks. But by applying Newton's laws of motion by the logic, um, this is not constant. So therefore, coefficient values, if you want to put a coefficient value, it's never going to be constant. The only thing this is the maximum value of the coefficient for the static friction. Keep that in mind, folks. This is not constant. And this will always have to be the case in order for the forces. Did I put, what did I, this will always be the case. Let me redraw this because I kind of put the components wrong. I meant to put cosine of theta. uh, minus f, and I think that's it. It's just going to be 0. So this would always have to be the case where the friction is depending on how much force you put it, the component of that force. So the sum of the forces in the y, however, is going to be the normal force minus p sine of theta minus mg. So therefore, the normal force will always have to equal p sine of theta. That's going to equal 0. Um, down, down, it's negative. So yeah, these are correct. So whatever it is, they have to be added values. So the normal force has to be those added values. And the friction, so the normal force, the maximum value of this will equal the coefficient times the normal force. And the normal force is P sine of theta added to gravity. So the more, so because you're pushing at an angle, you're pushing at some other component. You know what, to be honest, I can't explain for shit. So I'm just gonna put this in the calculator. Anyway, so I'm gonna store this. U. All right. So this is gonna be the maximum value, and because that's the max for the block to remain stationary, this right here would have to be less than, because this is the friction value, would have to be less than this. So this would have to be greater than this, because if it's not, then it's kinetic friction instead. Anyway, so this is P cosine of theta. So notice, folks, all I did is just thought about Newton's laws of motions, thought about the case where what happens when P is this. So these are all the possible combinations of P in order for this value to remain stationary. So let's kind of test this. Let's test all those values. So if P is 0, right? Let's say if P is 0, does this equation hold true? Well, no, because is this greater than, oh, it is. Oh my God. Oh yeah, it is. It is true. Okay, so fantastic. So we just saw for the case where if P is 0, this would always have to be the case. Now, if P, now let's find P where the values are equal to each other, because that's where the values is going to migrate their signs. So that means that this won't hold true after the. So let's solve for this. Static friction, P sine of theta plus mg. I'm just going to do the math here. Equals to the P cosine of theta. So let's find the values where this is equal. So the coefficient of static, P sine of theta. I'm just going to go fast and I'm going to go really slap it here because why the heck not? Mg equals P cosine of theta, because you guys can do the math, right? Yeah, I'm gonna fucking more. Anyways, so therefore, P would have to be equal to the coefficient of static friction, Mg, over the course of the, I'm going to move that over there, so I'm going to treat this as cosine of theta, factor it out, minus the coefficient of static friction, sine of theta. Beautiful. We really thought this video would be so much better, but it sucks, but that's okay. I really thought this video would be so much better, but that's okay. Oh yeah, let me write that down. Let me convert here so I can store this to the mass. All right, so I'm going to put this in the calculator. All right, the coefficient mg divided by cosine of theta minus the coefficient sine of theta. Let me see if I got the right angle. Nope, I don't. What's the angle? 37 degrees. Let me just write that down. There we go. Beautiful. Okay, P is 8.11 newtons. So in this case, the values for this block to remain stationary is going to be the values of P from all the way from 0 to its maximum value of 8.11 newtons. Fantastic. Anything greater than that, I'm going to store 9999, or actually you don't really have to store it. Think of it, oh, well, maybe you do. Yeah, maybe you kind of do. If the coefficient of that is 0.72 times sine of that angle, 37 degrees, is greater. So anything greater than that, this value would be bigger than this, so this inequality will not hold true, so therefore the object is in motion. Fantastic, folks. So that is the hard part. Now, we're not going to solve for part A, part B, part C just yet. Let's describe all the possible values of P. So we just described the values from when P is 0 to 8.1, the acceleration of this block is 0. The acceleration of this block is 0 meters per second squared. Fantastic. Beautiful, folks. I hope you guys enjoyed this video. I hope you guys are finding this helpful, or maybe not. I don't know. Let me know what you guys think in the comments. Please be honest, because I suck at making videos. But I do understand the math pretty well, so all right, so let's find all the values where P is greater than this. All right, let's relook at this force diagram. So now, let me copy this. Let's reuse this, because it's really going to be the same looking diagram. Now that force is just going to be kinetic. So now you're going to talk about a situation where you're going to overcome the static friction and the block is in motion, and that coefficient is different. That's going to be a kinetic friction. That's going to be, this is where this value is going to be always constant. So that you're going to talk about P cosine of theta minus that value, which I'm going to convert right now, the coefficient of kinetic times the normal force, which is going to be the combination of gravity plus the pushing down on the block, P sine of theta. And that's going to be ma. So whatever the acceleration is, it will always have to always equal this value once the block will start to move. So notice right here that this is already the whole equation. Oh boy, well, we can always rearrange these variables. So anyways. So there we go, folks. There's the equation for the acceleration, depending on the values. So anything greater than 8.111 newtons is those values. All right, so now let's simplify this. So I'm going to do that right now. So I'm going to say that the acceleration of the block, in fact, I'll put it right here, of the block is going to be P cosine of theta minus this right here. So I'm going to factor out that. I can think of this as one variable, cosine of theta minus the coefficient of kinetic times the sine of theta. And we'll be left with the coefficient of kinetic times mg all over the mass. So the value of P is much greater than or equal to 8.11 newtons, then this value, then this whole block is going to turn into a kinetic friction, and therefore there's your equation. Hey, we're done. All right, let's answer what they're asking. All right, so now since we got all those cases out of the way, let's answer part A, part B, part C. So what's part A? Part A is find the acceleration of the block as a function of P. Well, I just did that. So in fact, let's just kind of graph this here. So as the function of P, and this is going to be the a-axis, anything from 0 to 8.11 newtons, the acceleration here, will always be 0. Anything from that, you're going to have a completely different static friction. So let me how am I going to do this? Whatever, it's a straight line. I don't know what that line, it's going to be a straight line with a positive slope, or the slope of this with the y-intercept of that. So then you can think of this as P. No, probably better if you don't. No, I don't think you have to worry about it, because this implies that this is greater than that value. So I'm just going to put that in their calculator, see see where the acceleration. All right, conveniently, I get some value that's 8 newtons here, or 8 meters per second square. So whatever, that's going to be a straight line. There you go. There's the value for the acceleration. I don't know if it's going to look exactly like that, but if you're going to put all the possible combinations, there it is, folks. So, but you don't have to put the graphic part in. What you could do is you can copy this down. So because in order for the block to remain stationary, the acceleration is 0. At the cases where this is true, anything greater than that, then you're going to have that equation. All right, part B. All right, the P is 5 newtons. Fantastic. Well, I already have this stored in the calculator. So I'm just going to put 5 newtons. This is presuming I put this in the calculator right. The acceleration is 0. I was going to mess that up. All right. I was going to put this in the calculator and put that in there. All right. So if P is 10. All right. Now this is where you can use that equation that I gave you guys. And then once you plug it in, the acceleration here is 10.81 meters per second square. That's where the block of motions. All right. Describe in words how the acceleration depends on P. Well, I just did. And I failed at that. How the acceleration depends on P is there. Okay, the acceleration, there's 2 different functions, folks. I like to think of it as 2 different functions because there's 2 different scenarios. And I'm going to describe this in my own words. If the block, and I have this picture here, so if the values of P is from 0 to 8.1 newtons, the acceleration is 0. The friction will be equal to whatever this component is, will always equal to whatever component you push P on. So therefore, the block is unstationary. Once you overcome static friction, the maximum value, then the block is in motion and you're going to have a different rubbing from the block. So you're going to have kinetic friction in there. So you're going to use a different coefficient. And you're going to use this one, and you're going to have this equation right there once you set up your Newton's laws of motion. So the acceleration is really depending on the P cosine of theta minus the friction, which is going to be depending on the, I kind of put these 2 equations together, but it's going to be P cosine of theta minus the coefficient times the normal force, which is going to be mg plus P sine of theta. So P sine of theta, and then this other one should be P, or maybe not, maybe it's fine. Yeah, minus mg, all that divided by the mass. And that's it, folks. I mean, that's pretty straightforward for you guys. I'm done.